My name is Jonas Tyni. I'm the co-founder of Tvinn. And today I'm going to talk to you about one of the big challenges when it comes to large-scale electrification of the transport industry. And to be able to reach our environmental goals and to reduce we need to reduce the emissions from the transport industry, as you've heard. And the road that the transport industry has chosen is electrification. And both Volvo Trucks and Scania have announced that 50% of their sales will be electric vehicles in 2030. But it's a kind of a big problem when it comes to electrification, and that is that the grid at many locations can't handle to deliver the power that is needed for charging these large scale electric fleets. A recent study done in the Netherlands predicts that commercial vehicles will need around 3,000 megawatts of power to be able to charge in 2035. And to give you an example of how much power that is, it's almost equal to what Forsmark nuclear power plant can produce. So it's a lot of power. So this is one of the challenges that we at Tvinn are working on solutions for. We offer services and products that accelerate the transition to a fossil-free society. And we're developing a smart energy platform that we call Tvinn Nebula, where we can control and optimize energy resources such as EV chargers and energy storage systems. And we use algorithms, machine learning, and AI to create flexibility and to unlock power capacity that can either reduce energy cost or can be used to increase the amount of electric vehicles. And the solution, the system, is based on 3 modules. One is smart charging module, where we schedule, prioritize, and optimize the charging of the vehicles. And this can unlock quite a lot of flexibility and capacity. And to use local energy production and maximize the usage of local energy production and cut even more power peaks, we can use energy storage. And our energy management system can control the energy storage based on the schedule from the electric vehicle fleet. And to create better total cost ownership for the electric transport system and better return on investment on energy storage, we can create secondary revenues from energy markets by controlling these energy resources and creating a sort of a virtual power plant. And we're at the moment targeting the transport industry, but this is a scalable solution that can be used in other industries also, where we can optimize and control both energy producing and energy consuming resources. And the pioneer when it comes to electrification of large fleets is the public transport sector. And we have a Vinnova, Swedish Innovation Agency financed project, where we together with leading companies in the industry, top researchers and innovative startups are creating both technical and commercial solutions to enable a large-scale electrification of the transport industry. And in the project, we are building a pilot at Largescale's depot in Västerås. And during the project, they will receive 17 electric Volvo buses. And I can today present some interesting figures from a thesis project that we're working on that is related to this project. And Largescale, they want to have 17 charging points that can deliver 50 kilowatt of power to each bus. And we can see that already today, without any smartness, they will have a challenge when it comes to the grid and a challenge when it comes to not going over the limit that they have received from the grid company. And they also have quite a small margin when it comes to the charging, before the buses need to go out in traffic. But with smartness and our optimization, we can create the flexibility and reduce the power that is needed for the charging with around 20%. And we can at the same time increase the margin that they have for the charging quite a lot. And this can translate into power savings of around 100,000 SEK per year, or that we can generate revenues from frequency balancing markets, for example, and earn about 150K per year. Or we can use the power to increase the amount of buses with about 6 buses without any grid extension. So these are quite interesting figures. To summarize, we at Tvinn offer services and software that can create these type of solutions. And together with strong partners, we can deliver turnkey solutions with local production, energy storage, and charging infrastructure. So if you want to know more, please contact me. And if you have any question, I'll be happy to answer them now.
Great. Thank you, Jonas. Let's see if we have any questions on the chat. And not yet. So I'll give you a question. Well, it's similar to before. When to an outsider, it looks like a fantastic approach to get more buses charged in the station and all of that. But why are not everybody jumping into your projects? I mean, are the bus companies, the operators, all those companies really eager to get going with this?
Yeah, they are, and we are in discussion with quite a lot of transport operators, and we have had discussions with the different types of transport companies that have the problem when they want to convert to large-scale electrification, that the facilities that they have their depots in, they can't deliver the power that is needed. And some of the ones that we have discussed with, they had to cancel the electrification projects and turn over to other types of fuel, biofuels, and so on. Yeah. So there's a large interest in this. But still, we haven't seen. I mean, there are not so many really large-scale electrified transport systems today. Most of the bus companies, which are the first movers, they've had around like 10 buses or something like that. But Transdev, who is in the project now, they will have now the biggest implementation of electric buses in Sweden, and they will have around 160 buses in Göteborg. Okay. So then they are like the first one that's going to have this really large scale system, and that's a whole other business than having 10. So the buses are first out, but the trucks are coming after, and the delivery trucks and all that. So
your platform does your platform need a lot of customization for every single implementation, or is it very scalable, or how does it look like?
Well, it's scalable in one way, and another way it needs some adaptations to the local infrastructure that we have. But of course, that will the need for a specific implementation or integrations, they will, of course, will reduce over time. But I mean, it's an API-based system. We can integrate with a lot of other systems. So the idea is to not, for the transport operator, is not to like change system, or it's so that we can be an added value to them. Yeah. And so it's built in that way. So it's as scalable as it can be.